Hello, everybody. My name is Fadia Veit. I'm a Udacity session lead for Amazon Web Services Machine Learning Engineer Nanodegree. And today we'll take you through a walkthrough of Project 2, building a machine learning workflow for Scones Unlimited on Amazon SageMaker. Our project is an image classification project. We have two classes of images, bicycles and motorbikes. We will use Cypher 100 dataset from which we will extract our training and testing images. We will extract, transform, and load our dataset to an S3 bucket, and then we will train an image classifier on Amazon SageMaker. Then we will deploy an endpoint to serve the trained model. We will also use Amazon Web Services Lambda and step functions to load the test images, pass these images to the deployed endpoint, and get inferences. Then finally, we will filter the inferences obtained from the endpoint. Finally, we'll examine the output for our endpoints using Model Monitor and visualize our endpoint output probabilities. First, we open our SageMaker from an Amazon Web Services console. Then we click Open Our Studio. After that, when our studio loads, we go to the root directory and clone our project starter code repository. Then we open the project and then start the starter notebook. First, we select the kernel. The kernel should be data science and image of data science and kernel Python 3. We select the kernel and wait for it to load. Let's first examine our dataset. Our dataset is named Cypher 100. Cypher 100, the dataset consists of 60,000 32 by 32 color images, which are grouped into 100 classes. This is the dataset description here, and the Cypher 100 dataset is grouped into is divided into 100 classes. Each class contains 600 images. 500 of them are training images, and 100 of them are the test images. The 100 classes are grouped into 20 super classes. The class names are called fine labels, and the superclass names are called coarse labels. Here, first part of our notebook will download this data set, extracts the data from it, transforms them, and loads them to an S3 bucket. In our notebook, our first cell downloads the Cypher 100 data from the internet and then extracts it to a local directory. Your job in this notebook is to complete the 9 lines marked by to do in the comments and run your code. Let's examine our dataset file. Our downloaded dataset file named Cypher 100 python.tar.gz is a zipped archive that contains 3 files. When we extract, we get 3 files: the train, the test, and the meta, which are pickled Python dictionaries. The meta file is a Python dictionary that has the metadata of the project. Fine label names, which is a list of 100 classes, including the bicycles and the motorbike, and the coarse label names, which is a list of 20 elements that denote the superclass names of our datasets. Our train and test are also Python dictionaries, and they have 5 keys: file names, batch labels, fine labels, coarse labels, and data. We are concerned of file names and fine labels and data. The file names are the image names of inside our dataset, are listed here in a length of 60,000 images. And our fine labels is a numeric list, a numeric pointing to numeric indices of our fine label names. These numeric indices correspond to the indices of these fine label names in the metadata dictionary. Here in this project, we will transform these fine labels, 8 denoting a bicycle and 48 denoting a motorbike, to labels 0 and 1, which will be used by our image classifier. Finally, our data is a list of length of 60,000 that contains the list of lists. Each list of these is a numeric array that has the actual image data, binary of image data. This list has a length of 32 times 32 times 3. The first 32 denotes the width, and the 32 denoting the height, and 3 channels: red, green, and blue. In the next section, we transform our data into a usable shape and format. We first extract our gzipped file, tar.gz file, to the file system. When we extract this file, we obtain 3 files: meta, the test, and the train files. And then we load each file of these using pickle to a Python dictionary dataset meta, dataset test, and then dataset train. Here in this cell, we examine the training dataset keys, and then we use NumPy to transform our image data numeric array to a usable form that can be plotted using matplot library. Then we isolate the motorbike and bicycle classes, which have the labels 8 and 48 respectively. Then we use pandas to extract only the file names and the image data of the motorbikes and bicycles. Finally, we save the data inside the train and test pickle dictionaries to the file system. First, we create the training and testing directories in the file on the file system. Then we stack the images using NumPy. Then we save the images using the image file names and the image arrays on the file system inside the train and test directories that we created. And finally, we upload the train and test directories to an S3 bucket. After completing this step, we note that we have the test and train directories here in the file system. And then when we synchronize these two directories to an S3 bucket, we open the S3 bucket. We should note that we have the test and train directories here in the S3 bucket. If we open the train directory, for example, we can see our image files inside the bucket like this, bicycles and the motorbikes images. In the next section, we create two tab-separated value two manifest files, the train and test manifest files. These manifest files point to test and train images files on the file system. Then we upload these two manifest files to S3 bucket. After this step, we see that we have the test.lst and the train.lst. These two files are our manifest files. If we examine our manifest files, the train.lst, we see it tab-separated value file like this. The first column contains the indices inside the Cypher 100 dataset. These indices range from 0 to 60,000. The second column contains the labels of our dataset. This can be either 0, which represents a bicycle, and 1, which represents a motorbike. The third column contains the image file names inside the training channel. Here for the training.lst and for the test.lst contains the file names inside the test channel. After we upload these two manifest files to an S3 bucket, we see them beside our uploaded test and train directories. Next, we start our image training. First, we retrieve the latest pre-built container that contains the image classification algorithm here in this cell. And then we define the S3 output location that we will output the model artifacts to. Then we define our SageMaker estimator using the container that we obtained in the previous cell. And we use the instance of ml.p3.2xlarge compute instance to train our training job. This ml.p3.2xlarge compute instance has 8 CPUs and has 61 GB memory. It also has an NVIDIA GPU, and our image classification image we can use CUDA to access this GPU and train our machine learning models. This image costs, this compute instance costs $3.8 per hour. Then we define our image classifier model hyperparameters. We can see our hyperparameters here in this page will be provided in the resources. We can fill these 3 hyperparameters: the image shape, the number of classes, and the number of training samples. The image shape should be filled like this, in this format. First the channel, then the width, then the height, like this string. Finally, we define the input channels, the training directory that contains the image files, the test directory, the training manifest file, and the test manifest file. These are the 4 objects that we define in our image in our input channels. These are the 4 objects inside our S3 bucket that we have uploaded in the previous step. Finally, we start to launch a training job in this cell. When we launch a training job, we can see the progress of our training job in the SageMaker console here. On the left-hand side, we go to the training, then the training jobs. We can see our training job on the top of this list. If it's running, it will say that it's running. And if it has completed, we will see that its job status is completed. Our image classification using the compute instance that we have defined takes roughly 18 minutes to complete. And we can click on this training job and we can access all the data that was related to the training job. After our training job completes, we can open our S3 bucket, and then we'll see a new models directory that was created. If we open it, we find the image model, the training job name, then the output. In this directory, you'll find the model.tar.gz. This is the model artifact that we will use to deploy our endpoint in the next step. Next, you deploy your model. First, you define your model monitor data capture config object, passing the S3 URI of the data capture directory, in which the model monitor will output important information about the deployed endpoint, including the inference statistics. Next, you deploy your model on an ml.m5.x large image. Here you deploy your model, and you note the endpoint name here. Then you instantiate a predictor from your deployed endpoint name here. If you deploy your endpoint successfully, you can open your SageMaker, and you can see this deployed endpoint here underneath the on the left-hand side menu, underneath the inference, then endpoints. You will see deployed endpoints here in this screen. Then you test your endpoint deployment by opening an image serializer, and you open a test image from the local file system and so from the test directory. Then you pass the serializer to your predictor object, and you pass your object to your endpoint to get inferences. This inference object is a list of two floating point numbers. The first number denotes the probability of the image being a bicycle, and the second number denotes the probability of the image being a motorbike. Then you print the inferences to see the output of the endpoint predictions. Now let's move to the next part. Here we define our Lambda functions and the step function workflow. Here we are given the test objects and the stubs of 3 Lambda functions. The first one, this is the second one, and this is the third Lambda function. We will create 3 Lambda functions and chain them together inside a step function workflow. Let's examine the step function workflow. Here we examine our step function workflow. First, we pass a test event as a Python dictionary. Our test event has 3 keys: the S3 bucket, which contains the bucket name of the input data; the S3 key, which contains a path string path to the test image that we will do inferences on; and the third key is an empty string of the image data. We pass this test object to the first Lambda function, which reads the image data from S3 and then serializes the image. It encodes the read image into base 64 encoding. The output of the first Lambda function is a base 64 encoded image, and this encoded image is attached to the key inside the body of the event. This image data is encoded as base 64 image as a string, a byte string like this. Then this event is passed to the next Lambda function, which classifies the image. First, the second Lambda function first decodes this base 64 image, then it passes it to the endpoint, and from the endpoint it gets inferences. The inferences is a list of 2 floating point numbers. The first floating point numbers is the probability of the image being a bicycle, and the second floating point number is the probability of the image being a motorbike. The endpoint, the model monitor configuration, outputs its data into the S3 bucket data capture directory. This output of the model monitor will be examined in the final step of the notebook. Then we pass this event object to the third Lambda function, which filters our inferences according to a certain threshold. Here we take as an example a threshold of 0.7. If our inferences, the highest probability of our inferences is above this threshold, the function should pass the event it got from the previous Lambda function and pass it as an output, as it is. If the highest probability is below this threshold, the function should fail loudly, emitting a threshold confidence not met exception. It is important to note that the first Lambda function has an S3 full access rule. The second Lambda function should have a SageMaker full access policy attached to its role. And for the whole step function, it should have Lambda full access rule. To create our Lambda functions, we in the Lambda function console, in the Amazon SageMaker AWS console, we copy the Lambda function stubs inside the code editor like this. And each time we test, we create a test event. For the first Lambda function, if we completed the Lambda function successfully and we run the test event, we will get a response like this. Then to test the chain of our Lambda functions, we copy this response and we make it as a test event for the second Lambda function. We open this test tab, we paste the event here, and we save it. We give it a name like this, test event, and we save it. For our second Lambda function here, this is the code of our second Lambda function. Here we import SageMaker, but if we test our Lambda function, we get an error message indicating that our no module named SageMaker. So we will import the dependencies of this Lambda function as a layer here. We will package our SageMaker codes and we will import it inside our AWS Lambda as a layer. Then we will use this layer in our second Lambda function. Let's see how we can do this. Our SageMaker studio, we will go to the root directory first. Then we will launch a new terminal. Then we create a directory named Python mk there, Python. We will see this directory in the left-hand side top directory here. Then we did install target Python directory, SageMaker. And we click enter, the pip installs our SageMaker dependencies inside this Python directory. It takes a little while to fetch the dependencies from the internet and downloads them to this directory. We will wait until this process finishes and the prompt is displayed again. Here our dependencies are downloaded inside the Python directory. Now our SageMaker and its dependencies are installed. We should see the prompt again. And if we examine the Python directory, you'll see that it has downloaded all the dependencies of the Python SageMaker and find its dependent libraries. We go back to our root directory. One note is that this Python directory should be named like this exactly, with the capital, all the letters are P small and all the letters are small in the case. Then we zip this Python directory. We create a zipped archive of this Python directory. First, we install zip. We type sudo yum install zip. Then we zip the Python directory, zip -r SageMaker, so zip Python. Now our zip command zips our Python directory to our zip archive. When our zip commands finishes, we should see a SageMaker.zip archive. Next, we upload this SageMaker.zip file to an S3 bucket in order to import it to Lambda as a Lambda layer. First, we create our S3 bucket. Then we upload this zip the archive to our bucket by typing AWS S3 cp SageMaker.zip S3 URI of the bucket. Okay, now our SageMaker.zip is uploaded to this S3 bucket. Okay, we click this zip archive, we copy the S3 or I of the zip archive, then we go to our Lambda. Here in our Lambda, we create our layer. We open the layers from the AWS Lambda on the left hand side menu. We open the layers. We see that our layers are empty. We have no layers yet. Then we create a layer. We name our layer SageMaker. And then here we select upload from an Amazon S3. We paste the URI of the SageMaker.zip archive that we have uploaded before. Then we choose the runtime as the Python 3.9 runtime. By the way, we should create all our Lambda functions to use this Python 3.9 runtime in order to be compatible with this SageMaker dependency. Then we create our layer. Now our layer was created. We go back to our Lambda 2 function. This function failed because we couldn't import the module SageMaker. And now we will add this layer to it. Here we in the function overview at the top, we see the layers, this layers button. If we click on it, we'll jump below to the layers section of the page. We add a layer, we click add layer button. And here we choose custom layers, and we will choose the layer that we have created before. Name is SageMaker. We click on it, and then we click the version, the layer that we latest version that we have created. And then we add this layer to our function. Now to test the working of our layer, we can click test again. And our response should return the status code successfully and return the event without any problems or without any import problems. Back to our function, our draft step function and the Lambda functions. After we finish creating the Lambda functions and the step function, we should export our Lambda functions. Inside, we create a directory of Lambda functions here. Inside this directory, we export, we write the code of our Lambda functions in these three Python files: lambda1.py, lambda2.py, and lambda3.py. And we also take a screenshot of the running step function, a successful running step function screenshot, and we take a screenshot of step function when threshold not met. Finally, we export the step function in JSON definition inside our JSON file here. In the final step, we do testing and evaluation around running endpoints and step function. Here in this cell, we generate test cases. By running this cell multiple times, we generate test dictionaries that we can use as input to our step function. And if we define our model configuration correctly, when we open our S3 bucket, we can see here a data capture dictionary, data capture directory here. If we open this data capture, and we will see each one of the image classification endpoints sorted by year, day, month, day, and hour. We can see each one of the endpoint outputs this .jsonl file. If we open this JSONL file in our notebook, we can see that it has it has a Python dictionary. The Python dictionary contains the data that was given to the endpoint and the inferences output from the endpoint. Here are the inferences that were output by the endpoints, and attached to it a timestamp of the inference time. If we go back to our notebook and then we run this S3 downloader, we download these .jsonl files from the data capture directory. Then we parse these data downloaded JSONL files. Then we parse the inferences and the inference time here. And then we plot them. You generate a visualization of the plot of the inferences and the threshold that was defined in the previous step. Finally, after you finish the project, you just download this notebook as an HTML file here. And then you create a compressed zip file with these objects, the Lambda functions, 3 Lambda functions, codes, and the screenshots of the 2 screenshots of the working step function and the threshold not met. the step function definition JSON file, the project notebook, and the project notebook HTML output. You create a zip file of all these files and submit it to the project submission page. Thank you for listening and good luck with your second project.